Here's an example of how to work with growth or decay equations, including how to write them. Number one, in 2007, the forest covered an area of 2,400 square kilometers. Since then, the area has decreased by 8.75% each year. Let T be the number of years since 2007, and let A be the area of the forest in square kilometers. Write the exponential function showing the relationship between A and T. So our general exponential function looks like this. A equals A naught B to the power T. A naught is the initial value, which is 2,400 square kilometers for us. B is your growth or decay factor. For us, the function is decreasing, so it's going to be a decaying function. For decay, B equals 1 minus R. Now, R is the percent, 8.75%, but we cannot put the percent into this equation. It doesn't work with percents. It has to be converted to a decimal number. So divide by 100, 0.0875 to convert R from percent to a decimal. So now that you know R, you can actually calculate B. 1 minus R, which is 1 minus 0.0875, which is 0.9125. Do not truncate or round any of these numbers. They will end up in a round off error. So the actual equation, we're going to put it all together. The actual equation, then plugging in A naught and the B value into the general equation. A equals A naught is 2,400. B is 0.9125. And then T is an exponent on that number. Now, part B depends on part A. You need to use the function that you created in part A to calculate the area of the forest in 2026. So since the area has been decaying since 2007, so the measurements did not start until 2007, we actually have to calculate the value of T. We cannot just plug into the 2026. It's not going to work. T is the difference between the 2 years. So 2026 minus 2007, which will end up to be 19 years. And that's what we're going to plug into the formula above. So A equals 2,400 times 0.9125 to the 19th power, and then calculator work. That is going to be 421.34. In general, we round to the nearest whole number, so 421 square kilometers. Here's the next question. At the beginning of a population study, a city has 330,000 people each year since the population has grown by 5.4%. Let T be the number of years since the start of the study and P be the population. Write an exponential function showing the relationship between P and T. So P equals P naught, B to the T, that's the general equation. P naught is the initial population size, so 330,000. B, this is a growth problem. B is 1 plus R. R is 5.4% or 0.054 in a decimal format. So B then is 1 plus 0.054, so 1.054. Now, putting it all together into an actual function. P equals P naught is 330,000. B is 1.054 to the power T. This is the function that relates P and T. Part B, use that function that you just created to figure out the population after 7 years. So T is 7, and we just need to find the value of P. So P equals 330,000 times 1.054 to the 7th power. And that is 476 868.039, and we round the populations to the nearest whole person. We don't want fractions of people laying around.